Hi everyone, my name is Shelby Malto and I'm a meteorologist at the National Weather Service in Springfield, Missouri. And we're going to be spending a few minutes talking about meteorology, especially when it comes to severe weather. So, what is meteorology? Meteorology is the branch of science that's concerned with the processes of the atmosphere, especially when we're talking about forecasting the weather. So, during your day to day lives, you might hear that skies are going to be sunny, or you might hear that it's going to be raining, or maybe even getting severe weather. So, that is all talking about forecasting the weather in the atmosphere. So, that is all meteorology. So, first of all, before we start talking more about severe weather, let's talk a little bit more about the National Weather Service. So, who are we? So, the National Weather Service is composed of 122 forecast offices across the entire United States. So, each of these different color coded areas is an area that's covered by a different National Weather Service office. So, the National Weather Service in Springfield, where I'm located, covers portions of far southeast Kansas. We cover 3 counties in southeast Kansas and 34 counties in southwest and central Missouri. So, we forecast the weather for 37 counties, and that includes doing daily forecasts. It also includes doing severe thunderstorm or tornado or flash flood warnings. So, if you are in southwest Missouri or far southeast Kansas, and if you've ever been in a severe thunderstorm warning or a tornado warning, that's come from our specific forecast office here in Springfield. Same thing goes for wherever you are in the United States. Wherever you are, if you've ever been in a specific severe thunderstorm warning or tornado warning, that came from whichever office covers that specific area. So, before we dive deeper into severe weather, we first have to talk about clouds. So, there's a bunch of different types of clouds, and this graphic kind of shows a little bit more about those. So, we have our low clouds here at the bottom of the screen. So, low clouds can be our cumulus clouds. So, if you look outside and there's kind of these big, puffy white clouds, those are cumulus clouds. They can also be our stratus clouds. So, stratus clouds kind of look like a big blanket of clouds covering the entire sky. Sometimes they can bring rain with them, or if we're in the winter months, they can bring snow. So, those are going to be our low clouds. Then you go up a little bit, and we have our middle clouds that are a little bit higher up into the atmosphere. So that could be altocumulus, which kind of still looks like maybe some puffy clouds just a little bit higher in the sky. And then altostratus, same thing, kind of the blanket of clouds that's just a little bit higher. And then finally, we have our high clouds, which could be cirrus clouds right here. And cirrus clouds kind of just look like pretty thin, wispy clouds, kind of like feathers in the sky. And then different types of cirrus clouds as well. So we have a bunch of different types of clouds, both from low, then to middle, and then to high levels of the atmosphere. Now, when we talk about severe weather, the main type of cloud we're going to be talking about is this cloud on the far right, which is called the cumulonimbus cloud. Now notice our cumulonimbus cloud extends all the way from the low levels all the way up into the high levels. So that cumulonimbus cloud, because it's such a tall cloud, that's going to allow all of our precipitation to maybe start freezing and produce some hail. It's going to allow some electric charges to produce some lightning. So our cumulonimbus cloud is often referred to as the thunderstorm cloud. So here is just a brief time lapse of these cumulonimbus clouds forming. So you can see how we have these cumulus clouds that are starting to build up. And this is a time lapse over several hours. So you're going to notice if you focus on the right side, notice here in a bit how that cloud just builds up and it shoots up. And now we have our cumulonimbus cloud. So that's kind of how these clouds formed, from cumulus clouds towering up and then forming that cumulonimbus cloud. So these are the types of clouds that end up forming thunderstorms. So how do thunderstorms form? So if you think of when you're baking a cake, you need all different types of ingredients. So you're putting all of the ingredients on your counter and you're looking at them and you have the ingredients there, you just don't have the cake yet because you haven't put it all together. But when you put all of those different ingredients together, the flour, the sugar, the butter, all of those ingredients come together and then you put it in the oven, that's when you start getting the cake. So it's the same idea when we're talking about thunderstorms. You need three ingredients to come together in order for thunderstorms to even be possible. So the first ingredient here on the left is moisture. You need a lot of moisture that comes into an area, and that moisture is going to allow those cumulonimbus clouds to form and develop. So when we're talking about here in the central United States, sometimes or most of the time, our moisture comes down from the Gulf. So all of that moisture up in the Gulf goes up into the central portions of the United States. Now, if you're on the East Coast, it can still come from the Gulf or it can come from the Atlantic Ocean. And then if you're on the West Coast, it can come from the Pacific Ocean. But you need ample amounts of moisture. So that's our first ingredient. Our second ingredient is some form of lift. So what is lift? Lift can be in the form of what we call a cold front or a frontal boundary. Now, speaking specifically of cold fronts, if you look at this image, a cold front is this blue line here with these blue triangles. And what a cold front shows is when you have cold air behind this front, cold air is moving into an area that used to have warm air. So a cold front or a lifting mechanism is going to be that push that lifts all the air up right ahead of that cold front up into the atmosphere. So we need a lifting mechanism. And then the third ingredient that we need for thunderstorms to form is called instability. So instability is just the ability of that air to keep pushing up into the atmosphere after that lifting mechanism gives it that initial push. So instability can be thought of in terms of a hot air balloon. So if you've ever been in a hot air balloon or maybe you've seen one in the sky, typically you have the basket where people usually are, and then you have this big balloon. And inside the balloon is typically some way to start a fire. So a fire is started, and all of the hot air from that fire rises up into that balloon. And that's what allows that balloon to keep climbing up into the sky. So instability is kind of the same idea. So if you go back to our cold front here in this middle picture, ahead of a cold front, you typically have a lot of warm air. And typically it's warm, moist air because remember, we have a lot of moisture. So if you have warm, moist air, typically warm air is less dense than cold air. So this cold front is going to come through, bringing in all of this colder air. So all of that colder air coming in is a lot more dense, so it's going to want to stay towards the ground. So as our cold front comes in, it's going to push up all of that warm air up into the sky, into the atmosphere, causing that initial lift. And because we have an unstable atmosphere, we have instability because of that warm, moist air, that air is going to continue rising up into the atmosphere. And that's going to allow our thunderstorm clouds or our cumulonimbus clouds to form. So you need all of these three ingredients in order for thunderstorms to even be possible. We need the moisture, the lift, and the instability. So here's a graph of the annual mean thunderstorm days. So this is taken from about 1993 up until 2018. So this is just showing on average how many days per year certain areas see thunderstorms. So we're going to focus first on Southwest Missouri because that's where our office is located. So for Southwest Missouri, you see kind of this darker green color. So if we look at our legend, Southwest Missouri sees anywhere from 54 to 63 days per year of thunderstorms. Now, this isn't an exact number. Some years we see a lot less than 54. Some years we can even see more than 63 days per year. But on average, anywhere from 54 to 63 days a year, we can experience thunderstorms. Now, if you look over at Florida, you're going to see pretty uh, warm colors there. So you see those oranges, even the dark oranges into kind of the red colors there. So that's showing that portions of Florida can see anywhere from 99 to over 108 days per year of thunderstorms. So why is that? If you think back to the three different ingredients that we need in order for thunderstorms to form, one of the ingredients is ample amounts of moisture. And if you look at Florida, Florida is surrounded by moisture. So you have so much moisture in the atmosphere in Florida. So all you need is instability, which Florida can get pretty warm. They can get pretty hot, especially during the summertime there. So all of that warm, moist air is just waiting for a lifting mechanism or a frontal boundary to come through and lift all of that air. So you have all of the ingredients coming together a lot more in Florida. So that's why they see a lot more days per year of thunderstorms. So before we get into the different types of severe thunderstorms, every thunderstorm is going to have lightning. So you cannot have a thunderstorm without lightning. Some lightning is called intercloud lightning, where it's just lightning that bounces from cloud to cloud. Other uh, thunderstorms can produce lightning that's cloud to ground. So it travels from the cloud and then it strikes the ground. But regardless the type of lightning, every single thunderstorm is going to cause lightning. And lightning can be pretty dangerous. So lightning can get 5 times hotter than the surface of the sun, which can potentially reach temperatures around 50,000 degrees Fahrenheit. So anytime that you know that a thunderstorm is coming, you're going to have lightning with that storm, and that lightning is going to be pretty hazardous. So it's really important to know how to stay safe when you have a thunderstorm coming through. So here at the National Weather Service, we have a saying, and that saying is, when thunder roars, go indoors. It's essentially saying to stop all activities that are outside, go into shelter, whether it's a building or a hard-topped vehicle, and then just wait for that thunderstorm to move through, typically waiting about 30 minutes after that storm pushes through until that lightning threat is over. So if you're outside, maybe you're playing sports, if you're playing soccer or baseball, or maybe you're just outside reading or playing or taking a walk, whatever you're doing outside, if you hear thunder or if you know that a thunderstorm is coming for your area, go indoors. Take shelter so that you don't run the risk of getting struck by lightning. So that's lightning. Now we kind of get more into the severe hazards. So one severe hazard is hail. So some thunderstorms can produce hail, and those hailstones can vary in size. So some hailstones can be pretty small, about pea size, maybe even just penny or dime or nickel size. But some thunderstorms can produce larger hailstones, maybe about the size of a quarter, as we see in this left image here, maybe ranging up to the size of a tennis ball or a baseball, or maybe even greater. So, depending on the intensity of a thunderstorm, you could get pretty large hail, and hail can be pretty hazardous. So that one video played, I'll go ahead and play it again. But notice what these large hailstones are doing to these cars. They're just putting holes and dents into the windshields, into the cars. I mean, imagine if you were outside and these hailstones were hitting you. That could be extremely dangerous. So it's really important to know what to do if a thunderstorm is coming your way, because not only is it going to have lightning, as we saw before, but it could also be a severe thunderstorm with pretty large hail. So what causes hail to form? So this is just a pretty simple diagram of our cumulonimbus cloud, as you can see kind of in this background here. So really quick before we get into this, as you go up into the atmosphere, your temperatures start to decrease. That's why if you ever go for a hike, maybe out west in the mountains, and you're climbing a mountain and you're noticing that as you're getting higher up on that mountain, your temperatures are getting a lot colder. Maybe you're starting to bundle up. It's getting pretty cold. That's because our temperatures decrease with height. So back to our cumulonimbus cloud here. At the bottom of our cloud, we have what's called an updraft, which is this red arrow right here. And our updraft is just air that's being pushed up into our thunderstorm cloud. That updraft is allowing that cloud to continue rising up into the atmosphere like we saw in that time lapse a few slides ago. So we have our updraft, and we have small raindrops that are being sucked up into the updraft. So those raindrops are being pushed up and up into this cloud. Well, as those raindrops get higher and higher, now our temperatures are starting to go below freezing. So when you have liquid that's now below freezing, that's going to start to freeze. So those raindrops, as they're climbing up, now they're starting to get frozen. So we have all of these frozen raindrops now starting to be called hail. So those hailstones are now going to kind of circulate up into the cloud because they're going to rise up, be pushed up by the updraft, and then they're going to start falling down because gravity takes over. But then the updraft comes into play again and it pushes it back up. And that just repeats that cycle constantly until the hailstone gets so large that the updraft can no longer keep it suspended in the cloud. And that's when that hailstone starts to fall back to the earth in the form of a downdraft. So depending on how strong the updraft is, that ultimately depends on how big or how large those hailstones can get. And again, some hailstones are just pea size or maybe dime size, but some hailstones can get really large, maybe tennis or baseball size hail. In fact, the largest hailstone that's ever been recorded came from South Dakota back in 2010, and it was 8 inches in diameter. So this is a picture of that hailstone, and just imagine being outside while this 8-inch large hailstone is falling from the sky. That could do a lot of damage. So it's really, really important to stay safe when you know that a thunderstorm is coming because you're going to have lightning and you could potentially see some pretty large hail. So here's some hail safety. So if you're at home, the best thing to do is just head indoors immediately. If you hear thunder or if you know that a severe thunderstorm is coming for your area, go inside, and if you can, close all of the drapes or the blinds or the shades. Because remember, we saw that video of those large hailstones hitting the cars and how they shattered the windshields. Same thing could potentially happen with the windows in your house if those hailstones are large enough. So if you can, close all the drapes and the blinds and just stay away from the windows or skylights until that thunderstorm passes through. Now, if you're in a car, it gets a little bit trickier, but the best thing to do is to just stay in the car. If you have larger hail, just turning your back to the windows and covering yourself up with something just in case the glass on the windshields were to break. So just staying in the car, covering up until that thunderstorm passes. Those are going to be the best ways to stay safe if that thunderstorm does start producing large hail. So I do have a couple questions. I'm going to ask them and I'll go over the three different options for the answers. Now, teachers or whoever's watching, feel free to pause while students or anyone answers the questions, and then I'll show the answer afterwards. So for this first question, what ingredients need to be present in order for thunderstorms to form? Is it one, cold air, dry weather, and sunny skies? Two, moisture, lift, and instability? Or three, lightning, thunder, and hail? So go ahead and pause this video real quick and I will give the answer here in a second. All right, so hopefully you answered number two, moisture, lift, and instability. So remember, those three ingredients coming together allows thunderstorms to form. Next question, what should you do when thunder roars? Should you, number one, grab your camera, number two, run outside, or number three, go indoors? Go ahead and pause this video here. All right, remember our saying, when thunder roars, go indoors. All right, so now we're going to talk about tornadoes. So you can get thunderstorms that produce, well, every thunderstorm produces lightning. You can get thunderstorms that produce hail or maybe strong winds. And sometimes thunderstorms can produce tornadoes. Now, not every thunderstorm is going to produce a tornado. In fact, most do not produce a tornado. But sometimes you can see tornadoes produced from thunderstorms. So here's a couple pictures of some tornadoes, and notice how they look pretty different. You have one that's a lot more cone shaped, and then one that's a lot darker, a lot dirtier looking. So every tornado is going to look differently. Some are going to be pretty skinny, some might be pretty large. Some might be white in color, some might be dark in color. So every tornado is going to look different. So what is a tornado? This is a video showing just a tornado occurring in a field over in Kansas. Now, a tornado is a rapidly rotating column of air that extends down from our thunderstorm cloud all the way down to the ground. Now, because this is rapidly rotating and it's touching the ground, I'll go ahead and play it again here. It's going to start kicking up a lot of debris because you have pretty strong winds occurring at the base of this tornado. So you can kind of see some debris being lofted here. Now, this tornado is occurring in a field, so there's not much debris that this tornado is coming in contact with. So maybe some dirt, maybe some crops or grass, things like that. Now, if a tornado were to go through maybe a town, maybe it would start taking some shingles off of roofs, maybe pushing down trees or snapping trees, or maybe even causing some damage to buildings or cars. But that tornado is just a rapidly rotating column of air that extends down from that cumulonimbus cloud all the way down to the ground. So, how are tornadoes formed? Because remember, I said not every thunderstorm produces a tornado. In fact, most don't. So, if you go back to our thunderstorm ingredients, remember we need moisture, we need lift, and we need instability in order for thunderstorms to even be possible. So we have our three ingredients, but in order for tornadoes to be possible, we need a fourth ingredient. And that ingredient is called wind shear. Now, wind shear is just when your wind speeds or your wind directions change with height. So we're going to look here at this image. This left image here is showing our cumulonimbus cloud. And these black lines, these black arrows, are showing our wind speeds as we go up into the cloud. So notice that our arrows are all pretty much the same length, showing that our wind speeds aren't really changing with height. So maybe at the base of that cloud, our wind speeds are maybe 10 miles per hour. And then as we go up into the cloud, at the top of the cloud, maybe our wind speeds are 15 miles per hour. Really not that big of a difference. So when we have no wind shear at all, our thunderstorm cloud is going to rise up, just purely up, purely vertical into the sky. And then all of that moisture is going to end up dropping in the form of a downdraft. So we have all of our rain, maybe some smaller hail, that's just going to fall straight down and collapse on top of our updraft, which is this yellow arrow. And it's just going to end up killing that thunderstorm. So, this is typically what we see during the summertime here in the central US. So, typically in the summer, we call these our pulse thunderstorms or our single cell storms. And that's just when our thunderstorm cloud billows up vertically and then collapses down as all of that rain and maybe some small hail falls to the ground. Really nothing much to this thunderstorm. Maybe you could see some small hail, maybe some gusty winds, but really nothing too severe. Now, on the right-hand side of this image, this is when we have wind shear involved. So looking at our black arrows, notice how they're getting a lot longer as you go up into the atmosphere, into that thunderstorm cloud. So maybe at the base of our thunderstorm, maybe our winds are 25 miles per hour. And then at the top of that storm, maybe our winds are 70, 80 miles per hour. So what that's going to do is that's going to start tilting our thunderstorm cloud. So instead of our thunderstorm rising up completely vertical like the left side, now our thunderstorm cloud is tilted. And so what that allows that storm to do is that's going to drop all of this precipitation, all of the rain and hail away from the updraft where you have this orange arrow. And so because our precipitation is no longer collapsing our thunderstorm is going to be allowed to have a much longer life cycle. So it has a lot more time to become more intense of a storm, more severe, and maybe a lot more time to start rotating. And that's what's going to allow tornadoes to even be possible. It's when we have our wind shear, where our wind speeds or our wind directions change with height. So again, here's another graph of the average annual number of tornadoes per state. So this is from 1992 to 2021. So you can see on average how many tornadoes happen each year. And again, these aren't exact numbers. So some years you can see less than what's shown in this graph. Other years you could see a lot more than what's shown in this. But in general, again, we're going to kind of focus on Missouri. That's where my office is. So on average, Missouri can see anywhere around 46 tornadoes each year. Now notice how just left of Missouri, you see a lot more darker colors. So Kansas, you kind of have this reddish color. Oklahoma is kind of this darker orange color there with 66 tornadoes on average. And then look at Texas. Texas on average sees anywhere up to 139 tornadoes each year. So this is what we call Tornado Alley. It's just kind of this portion of the United States that does definitely see a lot more tornadoes every single year. And that's because that fourth ingredient, or our wind shear, is a lot more prominent in this area. So all four of those ingredients, the moisture, lift, instability, and wind shear, come together a lot more over this area. So that's why this is called Tornado Alley. But regardless of where you are in the United States, tornadoes are going to be possible anywhere. So you could be in Maine, you could be in Washington, you could be in Arizona. Wherever you are, tornadoes are going to be possible. But there's definitely an area of the US where they're a lot more common each year. So this is a look at what we call the Enhanced Fujita Scale, or the EF scale. So tornadoes are rated after the fact that they happen. So if you've ever heard of maybe an EF0 tornado or an EF3 or even an EF5 tornado, that's that enhanced Fujita scale. So we use this scale to rate the different intensities of each tornado, and we rate them based on the damage that they caused. So, for example, if we look at the EF0 tornadoes, typically EF0 tornadoes can have winds ranging from 65 to even 85 miles per hour. So, when you have an EF0 with those wind speeds, they can cause some minor damage, maybe blowing off some shingles, maybe part of a roof. Could definitely cause some damage to the siding, maybe some trees. So we're going to typically rate that sort of damage as an EF0. But if you look, now we're getting, as you go up in the scale, we're getting up to the strong tornadoes or even the violent tornadoes, all the way up to an EF5 tornado. EF5 tornadoes can have wind speeds greater than 200 miles per hour. So when we're talking about speeds greater than 200 miles per hour, that's going to cause some massive destructive damage. So that's going to allow well-constructed homes to just completely be swept away. Completely debarking trees, completely stripping branches, snapping trees, just incredible destructive damage. So that's how we rate different tornadoes. We rate it based on the damage that they cause. And that can range from our weaker tornadoes at EF0 all the way up to those violent EF4, EF5 tornadoes. So, again, kind of reinforcing that safety aspect. When there's a tornado that's coming towards your area, or even if tornadoes are possible within the next couple hours, it's really important to know where to go when you're taking shelter from a tornado. So the safest place, if you have a basement, that's going to be the best place to go. Somewhere kind of that lowest level, basements are underground, so that's much more safe if you have a basement or if you have a designated tornado shelter. But if you don't have either of those, going to the lowest level of a sturdy building in an interior room with no windows, that's going to be the safest place to go during a tornado or when you're sheltering from a tornado. Don't go outside. Don't go into exterior rooms with windows because those windows could blow in or that tornado could damage those exterior rooms. Don't go to higher ground unless you have flooding also occurring. Just going to the lowest level of a sturdy building. That's going to be the best place to take shelter. So, a couple more questions. So, question number 1, tornadoes can form in any state of the United States. Is that true or is that false? Go ahead and pause the video now. That is true. Tornadoes can form anywhere in the United States, but they are most common in what we call Tornado Alley, which is kind of that central portion of the United States. Question 2, where should you take shelter from a tornado when you're at home? Is it in the attic, in a bedroom with windows, downstairs, or outside? Go ahead and pause the video now. You should go downstairs. Remember, if you have a basement, that's the safest. But if you don't, the lowest level of a sturdy building in an interior room with no windows, that's going to be the safest place to shelter. All right, so we talked about hail and tornadoes and lightning. So now we're going to talk about flash floods. So taking a look at this video here, flash floods can be extremely dangerous. So flash flood happens when maybe you have a lot of rain that's falling. Maybe you have several thunderstorms that have just been repeatedly pouring heavy rain into an area. And when you have heavy rainfall that's happening over an extended period of time, your rivers, your lakes, your reservoirs, they're going to stop being able to collect that rain. They're going to start overtopping, and that's going to cause flooding to occur, and maybe even flooding into some streets, some low water crossings, or even causing, pretty substantial flooding. So you can kind of see the flooding that's happening on this highway here in this picture on the left, and then especially in this video. So flooding can, you see these cars being swept away by the floodwaters. They can get extremely dangerous very, very quickly. So a couple flash flood safety tips. The main thing to remember is just don't underestimate the power of water. So if you have a pencil or a pen nearby, go ahead and look at that pen. It's probably about maybe 6 inches long, maybe a little less. But 6 inches of fast-moving water can knock over and carry away an adult. So looking at that pen or pencil, just that amount of water that's moving pretty rapidly, that can knock over a full-grown adult. And then if you have 12 inches, so 1 foot of fast-moving water, that can carry away a small car. And then like we saw in the video in the previous slide, up to 2 feet of fast-moving water can carry away pretty much any large SUV or even any truck or large van. So don't underestimate the power of water. Flash floods can be extremely dangerous. So if you come across a flooded roadway, don't cross it. We have a saying here in the National Weather Service, and it's turn around, don't drown. So maybe you're outside, maybe you're taking a walk or taking a hike, and you come across flooded waters. Turn around, don't drown. Be patient and wait for that water to recede, or go and find a different route so that you don't have to cross those flooded roadways. All right, so now we're going to move towards hurricanes. So where I'm at here in Missouri, I really don't interact with hurricanes too much, but our coastal offices, especially Florida, maybe the East Coast, or those areas that touch the Gulf down south, those definitely see a lot of hurricanes each year during hurricane season. So I'm going to go ahead and play a video here, and it's going to talk a lot about hurricanes and how they form. And while you're watching this video, be listening for a couple things that we've talked about already during this presentation.
Hurricanes are very large and intense storms. But where do these giant storms come from? A hurricane starts with the warm water found near the equator. Hurricanes typically only form in tropical regions where the ocean is at least 80 degrees Fahrenheit. These warm waters evaporate, creating warm, moist air which acts as fuel for the storm. Wind is also needed for a hurricane to form. Many hurricanes in the United States are caused by winds blowing across the Atlantic Ocean from Africa. This wind causes even more of the warm water to evaporate into the air. The warm, moist air then rises high into the atmosphere, where it begins to cool. Way up there, the water vapor condenses back into liquid water droplets. Water droplets in the atmosphere form clouds, including big, stormy cumulonimbus clouds. As the warm air continues rising upward, the winds begin blowing in a circular pattern around a center. The spiraling winds gather up a cluster of big thunderstorm clouds. Once the spinning winds reach 74 miles per hour, the storm has officially become a hurricane. Hurricanes are huge. They can be 10 miles high and over 1,000 miles across. Once a hurricane hits land, it runs out of warm, moist air and its winds begin to weaken. But the storm can still cause lots of damage to communities near the coast. Thankfully, we have weather satellites that are constantly monitoring the conditions down here on Earth. The GOES are a series of weather satellites that scan the hemisphere every 10 minutes and the U.S. every 5 minutes, keeping an eye on conditions that might cause a hurricane to form. Once a hurricane forms, the satellites can help predict the storm's intensity and track it minute by minute. This information allows meteorologists to deliver early warnings and help people stay safe.
All right, so that's kind of how hurricanes form. There's a lot more that goes into it, but that can give you an idea of how they can form and then even, specific areas that they might impact, especially those coastal offices there. So within that video, you probably heard a couple things that we've already talked about. So you heard our thunderstorm clouds or our cumulonimbus clouds that billow up. You heard that warm, moist air that rises up into the atmosphere, allowing those thunderstorm clouds to form there. So that video kind of gives you an idea of how hurricanes can even form. So hurricanes aren't always called hurricanes. So it depends on where you are in the world. So obviously here in the Atlantic Ocean or even the Central and Eastern Pacific Oceans, we do call them hurricanes. But if you go to the Western Pacific Ocean, they're called typhoons, or in the Indian Ocean, they're called cyclones. They're also called cyclones off the coast of Australia, but those specific hurricanes or cyclones have a nickname called Willy Willies, which is kind of my favorite name for the hurricanes. But no matter where you are in the world, whether it's called a hurricane or a typhoon or a cyclone or a willy willy, they're all talking about the same thing. It's that large storm system that you saw in the video previously. And there's other types of severe weather that, for lack of time, we won't go into, but there's fire weather, there's droughts, there's extreme heat, or in the wintertime, extreme cold. There's blizzards and ice storms and even fog. Fog can even be pretty hazardous, and a lot of people don't realize that. But there's a bunch of different types of severe weather. So, how do meteorologists gather weather data? So, we talked about severe weather. So, now we're going to kind of pivot to talk more about meteorology and how we can even forecast severe weather from happening. And in order for us to be able to forecast the weather, we need to gather a bunch of data. So, one of the ways that we gather data is through weather balloons. So, weather balloons are launched 2 times a day at specific National Weather Service offices. And you can see a picture here. So, weather balloons are just these large latex balloons that are either filled with hydrogen or helium, depending on the specific office. So, you have this large latex balloon that's filled up, and attached to that balloon, we attach a really long string, and at the end of that string is attached a radiosonde. And a radiosonde is what you see in this middle image. And that radiosonde is collecting a bunch of data as that balloon rises up into the atmosphere. So this radiosonde is collecting the temperatures, it's collecting the pressure and the moisture, and just a bunch of great weather information and data that's then coming back to our computers. It's decoded, and we're able to use that information to forecast what could potentially happen, what the atmosphere is capable of doing. So I'll play this video again, and this is just showing us launching the weather balloon. So you see that weather balloon is being launched, and there's that long string that's attached to it, and then the radio sounds at the bottom. And you also see this kind of orange thing attached to it too. That's just a parachute, because that weather balloon is going to climb up and up to over 100,000 feet up in the air. And then once it can't climb any further, that balloon's going to pop and then it's going to come back down to Earth. So we have to attach that parachute. That way, as that radio sonde and the popped balloon travels back down to Earth, that parachute is going to allow it to travel a lot slower. That way we don't harm anyone at the surface. So we can collect data from our weather balloons. We also collect rain and snow measurements. And so we can collect rain in our rain gauges to see how much rain actually fell during an event. And that can help calibrate our radars so that our radar or our rain estimates can get as accurate as possible. And then same thing for the winter time. We can measure how much snow ended up falling using a snowboard and a ruler. We also have different weather stations placed across the entire United States, and that can be located at airports, that can be located at rivers or streams. Even some buoys have these weather stations. They can pretty much be anywhere, and they can give us information about the temperature, about the wind speed and direction, even about the cloud, how many clouds are in the sky, just different weather information like that. And it gives us the exact observations across the entire area. And that can help us not only know what's happening in real time, but that can also help us calibrate our forecasts to make sure that our forecasts are up to date with real-time observations. We also have weather satellites, and so a satellite is just a giant camera that's launched into space. And these satellites give us a bunch of different satellite images that help us detect clouds, can even help us detect temperature and moisture across the entire globe. And then finally, we have our radars. So if you've ever seen a radar, it looks like what's in this image here, and it kind of just looks like a giant volleyball that's on stilts. So radar stands for radio detection and ranging. And these radars help us see the rain, snow, hail, even help us see tornadoes that are out in the area. So during severe weather, we use radar constantly. We're able to see where storms are. We're able to see what storms are potentially producing. If they're potentially producing maybe quarter size hail or maybe tennis ball size hail, or even if they're producing a tornado. So we use radar every single day. So all of that data collection from our weather balloons, from our satellites, our radars, and our weather stations are all put into these giant supercomputers. And they do a bunch of math and a bunch of computations. And afterwards, they are able to spit out all of our different weather models. So we have over 100 weather models that we can see different potential outcomes in the weather. Maybe some models are saying it's going to rain, other models are saying it's going to be sunny skies. Maybe some models are saying that there's going to be severe weather. So we're able to see all of these different models and then apply meteorology to them in order to produce our weather forecast and be able to see what could potentially happen in the next several days, if we're going to get severe weather or if we're going to have sunny skies. So without that data collection, forecasting the weather is going to be pretty difficult. So we need all of those different methods in order for our forecast to be more accurate. So that is everything that I have. So that talks a little bit more about meteorology, what different data sets we can use to make our forecasts, but really talking about severe weather. So we learned about thunderstorms, lightning, hail, tornadoes, flash floods, and hurricanes. So hopefully this gave you a little bit more information on severe weather. Thank you for listening.